Now, the only section that you're going to be doing in your workbook this time around is this section. Pay attention to how I do these problems. That should help you with probably 90% of what's in section 8.1 in the workbook. No. No. After we take care of polygons, we will be taking a really fast look at parallelograms, rectangles, rhombi, or rhombses, and trapezoids and kites. Kite actually is a technical math term. There are certain characteristics of a mathematical kite. But that part of the chapter is reading, memorization, and characteristics of figures. The calculation work is not that difficult because what is the total amount of degrees inside of a square or a quadrilateral? 360. Can you guys add up to 360? Can you subtract from 360? That's mainly what you're doing the rest of the chapter, is grouping things either in pairs of 180 or collections of all four angles to 360. This is the technical part, or the calculation part of the entire chapter, and that's why you're doing that in the workbook. But that's the only workbook you're going to have. I might give you a few more worksheets that look like this that have to do with quadrilaterals, but that's about it. We're going to fly through this section. Then, hopefully after spring break, we will concentrate on circles. That takes a little bit longer. That, again, the calculation work is not that hard, but there's memorization to do. Underline, interior, double underline, sum, circle, octagon. Put the number that's associated with the name next to it. If you do these things, you're not going to have too much difficulty with this section. We had a formula that went along with interior. What was that formula? What did the N stand for? Well, we've got that. 8 minus 2 times 180, 6 times 180, and what is that? When you write your answer, make sure you're giving me a unit. Those are degrees, so you should have a degree symbol there. All we're doing is totaling up every single interior angle, and it turns out to be 1,080 degrees. Did that say anything about the figure being regular? No. So the sides of that octagon, 1, 2, 3, 4, 5, 6, 7, 8, could be any length. But everything that we're dealing with in this chapter and this year is going to be convex. What's the opposite of convex? Concave. Concave. So what you won't see are what I call Kermit the Frog heads. You will not see the shape indent into itself. All of the shapes will be convex. Do you understand the difference there? Yeah. The technical difference, if I make a diagonal within a convex shape, is it inside the figure or outside the figure? Inside. All diagonals of a convex figure will be inside. If you take something like a Kermit the Frog head, then technically that's a diagonal. It's touching two of the vertices of the figure, but is it inside? Diagonal turns out to be outside. When you have a diagonal that's outside the figure, then you've got yourself a concave figure. You might get into that in a higher level geometry course. This year, everything you assume to be convex. Number 1, are we good on that? Interior, sum, 12. Is that the same idea? So I'm using 12 minus 2 times 180 equals 10 10 times 180 equals 1,800 degrees. Always go back. For this section, it's easy to make a mistake. Go back and box in what it is that you are actually finding. We needed a sum, so we're expecting a larger number. We got a larger number. Double underline each. We're still in the interior. This time it's a regular octagon. That means 8. Measure each interior angle of a regular octagon. I'm going to show you 2 ways to do this. Somebody raise their hand, give me one way. What would you do if you're trying to figure out each angle instead of the sum?
Find the interior angle sum and divide by the number of sides.
So I'm still using this, correct? I'm still determining this, which I actually did up there. So that's 1,080. And then what's your last step?
Divide by the number of sides.
1,080 divided by 8. What is that?
135.
135. Box in what it was that you were trying to find. In this case, it was each angle. That's 135. Anytime regular shows up, regular, think division. It doesn't mean that you're always going to be doing that, but if regular is in there, that means everything's the same. That means that division is an option. I'm going to jump to this screen. What I would do is maybe put this in the left-hand margin, make a little sketch. If it's a regular octagon, what's that look like? Stop sign. 2, 3, 4, 5, 6, 7, 8. Put some slash marks on it. And let's move in a spiral pattern to create some exterior angles. I'm going to start here. I'm just going to move clockwise. I'm just going to extend each of these sides in this clockwise spiral pattern. Last class, we talked about all the rules you needed except for one more. You've got an interior angle and you've got an exterior angle. What do they form? If you're stuck on a problem, you're probably ignoring that fact. That whatever the interior is, you can subtract from 180 and you've got the exterior. Or vice versa. What did we say the rule was for the exterior of any shape that's convex? 360. Exterior equals 360. Let's say you forget what's going on with the interior. But you can remember that the exterior is 360. If it's regular, what did we say you should think about? Division. So, even though this is an interior problem, let's take it to the exterior. How many sides are there? 8, and they're all the same. But that also means that all of the interior angles are the same, which means that all of the exterior angles are the same.
What number are we?
We're still on number 3. I'm giving you an alternate way of looking at the situation. What's 360 divided by 8?
45.
45. That means that that's 45, that's 45. The only reason I can put 45s everywhere is because this is a regular shape. But what did I just say about interior and exterior? They're linear pairs. So if I know that that's 45, what does this have to be? 135. They're all 135 because this is regular. 135, etc. Is that the same answer that we got right here? So this is a interior angle procedure or path, but I could have easily gone to the outside and come back in. And the only reason I could do that was because it was a regular situation. But keep that in mind. If you're stuck on something, you're probably ignoring that the interior and the exterior form a linear pair. So if I see this, I might do what I did in number 3, or I might do this. Since I see that this is regular, what's 360 divided by 12?
30.
30? What is 30? That's the outside. So what does the inside have to be? Done. I could have done the n minus 2 times 180, got a total, divided that by 12, but if I know 360 is always the total on the outside, why not go through that? Always have a picture in your mind like that of what's going on when you're dealing with a regular figure. What is the exterior angle sum of an octagon? What's the exterior angle sum of any convex figure? 360. Don't overthink these. What's the measure of each exterior angle regular octagon? 45 degrees, and that's what we were looking at on the back of this. Right there.
Good morning. Please excuse this interruption. At this time, please release all students who have SOL passes to their respective labs. The following classes are testing: Ms. Dowling's Period 4 English, Mr. Alonzo's Period 2 English, Mr. Cresswell's Period 2 English, and Ms. Lawrence's Period 2 English. Thank you and have a good day.
How many sides does a regular polygon have if each interior angle is 156? This is the most important part of that question. If it's regular, what does that mean?
Division.
Possibly division, but in terms of the figure, it means that everything's the same. Not only the sides, but the interior angles and the exterior angles will all have something in common. I don't know how many sides this has, so I'm just going to sketch a little bit of it. 1, 2, 3. I might write down 3 sides, and I might show 2 spirals. So I'm not showing an entire figure. Maybe I'm just showing a little section of it. So the blue is the actual shape, and then these extensions create some exterior angles. I know that everything's the same. So if I have 156 there, I've got 156 there. I tend to jump to the outside because it's simpler. If that's 156, like it's been given to me, what is the exterior?
24.
24. All the way around, because what kind of shape is this? Regular. Well, what's the total on the outside supposed to be? What are you allowed to do if you've got a regular situation? Divide. What is each exterior? 24. So I'm taking degrees and dividing by degrees, and that's going to give me the sides. How many sides do I have?
15.
15. There are many paths to the same answer. I could have stayed with interior, but why not jump to the exterior and take a look at that amount? How many sides does a regular polygon have? So we're looking for sides. Each exterior angle is 72. We're already on the outside. I know the total's 360. They're telling me that each one is 72. How many sides? 5 sides. Sorry, for number 7, that should be sides, not angles. We needed sides. Number 9, sides, interior, sum, 1260. So we've got the big amounts. Does this say anything about regularity? No. Nothing about regular. What's the formula for the interior sum? N minus 2 times 180 equals what? In this case, 1260. You're working backwards. Instead of knowing the sides and finding the total, you've got the total, you got to use your algebra skills to figure out what n is. How would you get n all by itself? People who passed algebra. You could start that way. She wants to distribute first. Does it matter if 180 is before this or after this? It's still distributing. So that's 180n minus 360. How do you get n by itself with a two-step equation like this? 180n equals 1620. How do you get rid of the 180? A little bit of division. 180n divided by 180. 1620 divided by 180. Does that work out evenly, hopefully? 9? 9 what? We're looking for sides. You have a built-in check here. If you put in 9 into here and you don't get 1260, something went wrong. I heard Matt say something about trial and error. You can do trial and error. For some of these, they're smaller. You didn't say that? No. Were you thinking?
Yeah.
Did everybody understand that? Did she have to do distribution?
No.
How about if we just think in terms of opposite actions, what's the opposite action of multiplying by 180? So there's many algebraic ways to get to your answer as long as you're following correct steps and procedures. That was number 9. Always go back, make sure that you've answered the question. This is the one section of the tests and the quizzes for this chapter that sometimes confuse people. And it's only because they're moving too quickly through the questions. And this is geometry class. Make a picture sometimes if you don't have a picture. Are these figures for 10 and 11, are they regular? No. But they throw in some variables so I can make an equation. What's the total on any quadrilateral? 360. I don't even have to think about it. I could go through the n minus 2 times 180 process, but it's always going to be 360. This shape is the one shape that's 360 on the inside, and what is the outside always? 360. So for a quadrilateral, you don't have to think too hard. X plus 82 plus 10, is that 106? And 88 Can you solve for x in that equation? What do you get? How much? 84. You have a built-in check here. Add those up and make sure that they add up to 360. Number 11 is not a quadrilateral. What is it? Pentagon. So first, I need a total, like I had up here. What is 5 minus 2 times 180? 540? Just like up here, I have a new total. I have other things inside, but it doesn't matter. I'm still doing the same thing that I did up here. I'm adding up my components. I've got 2x plus 5. I've got a 4x minus 5. I've got a 2x in here. I've got an x plus 60. And I've got a 3x. These questions are designed just to see if you remember some of your basic like term skills and equation solving skills from algebra. Looks like we're just finding the value of x for both of these. What is x in this case?
40.
40? Does that need a degree measure or any sort of label? No. It's just a value. Do we like that? Only difference with these problems is that you don't have your picture. 5 of the angles of a hexagon look like that. What do you want to call the measure of the 6th angle? How about if we give it a variable name? This is why you learned your algebra, so that you could set up your own equations and solve them this year. That's great. I have 122 plus 110 plus 95 plus 108 plus 135 plus the 6th angle, which I'm calling x. All I need is a total for all of that. These are 5 of the angles. We're assuming that this is talking about your interior. What's the rule for interior? N minus 2 times 180, which would be, how many sides in a hexagon? 6. 6 minus 2 times 180, 4 times 180. So you are really solving this equation. What does x turn out to be for that?
150.
How much? 150? 13, we have a quad. Find the value of x and the measure of each angle. What would I set up for 13? What kind of equation? So you totaled up all of these?
Yeah.
He totaled up all of those. He got 23x plus 15. And what did he make it equal to? 360. For a quad, everything adds up to 360. Interior and exterior. And what was your x from that, Spence? 15. And did you then find the measure of each angle? What are each angles?
A is 115, B is 77, C is 91, D is 78.
115, 77, 90, and 78. Notice how I'm writing this. That's how you should be writing your answers. If you're talking about an equal sign, you should have a little m over here indicating measure, and you should have a degree symbol. Show me what we're talking about. Does everybody understand where I got 23x and 15 from, or where Spence got it from? All we're doing is adding up our pieces. If you can't visualize this, make a picture. Make it look like number 10, so you're actually looking at a quadrilateral. Measure of an interior angle of a polygon is 5 times the size of the exterior angle. Find the value of x. How many sides does the polygon have? All right, we can't do this unless one more word is added here. Right next to A, write down the word regular. Because otherwise, we're just looking at one interior angle and one exterior angle, and that's not really going to tell me anything if it's not regular. So I need the word regular in there. Once it's regular, I draw 3 pieces. I don't know how many sides there are, so I'm just drawing a little cross section of the entire figure. I extend a few of the sides so I can show exterior angles. The measure of an interior angle is 5 times the exterior. Where am I going to place the x?
On the outside.
On the outside. Put x degrees. It's telling me the interior is based off of the exterior. That's going to be your 5x. What do you know about x and 5x? What do they add up to? They add up to 180. 6x equals 180. X equals 30. Oops. That's just a value, so I just need 30. That's great. That means that the outside is 30. I'm telling you that it's regular. That's the only way we can do this problem. How do I then determine the number of sides? A bit of division. Outside's 360. It's got 30 degrees in each exterior angle now. And what does that give me? 12. 12 what? 12 sides. What is a 12-gon actually called? Decagon would be 10. Dodecagon. This is one that you might not have come across, but you are expected to know dodecagon. Yes.
What's 11?
11? I don't know. Because it's an amount that's not used too often. It's not used too often, so I don't know. Let's see if I can. Did I give you guys a worksheet at one point that showed how you name polygons? If you've still got that in your notes, take a look at it and see if you can figure out what 11-sided would be called. Most of the time you'll just see 11 gon, or you won't see it at all.
Credit. Credit.
Or maybe your project for work.
What does it look like?
We did it way long ago.
You can begin your workbook work, which is the only workbook work for this section.
I need to skip this.
There's really 4 basic ideas. I'm going to write them down on the sideboard. You can use them for the quiz. That'll eventually happen.
Oh, I know. I thought I lost it and I got another one.
Yeah, I mean, you don't even have to tell Josh. He was like, oh, I guess I'm not the one. Hey, God. God. I'm studying.